All right. So, before we get started here, a couple things. I've put up, and based off what it kind of covers, I put it under Module 7, but I posted the next Canvas discussion. So it won't be related to really what we talked about this week, although I could see you incorporating some of it. It's primarily going to be thinking about the combination of Modules 6 and 7, and the idea of subsidies and then externalities that could exist, either positive or negative to society, in respect to basically healthcare, right? And so I put up a couple links, as well as kind of a data source where you're looking at insurance, Medicare, Medicaid, the differences across states and how much is covered. So you can kind of think about this Medicare or Medicaid as like a subsidy, right? So as always, kind of read through the prompts, use the articles, come up with your initial post, thoughts about this idea, support it or kind of tie it to something from that data source, and then respond it to other students. And I have this set to be due at the end of the day next Friday. I actually got over a week to kind of get this done. I would suggest working on it sooner rather than later. These should be easy points if you're putting the effort in. You miss the due date, it's, it also hurts your grades a lot. So make sure you're getting these done quickly. After class today, kind of back to our normal routine, you'll see the next module quiz, and then I'll kind of have module 9's reading posted. They're both due by the end of the day on Monday. Okay. So we'll start, going to pick up, we'll cover module 9 next week. We then have spring break. We're then back for an exam review session on Tuesday and the exam that Thursday after spring break. Okay. So because of that, I also put up some practice materials for exam 2. So it's a little bit different. So I gave you 2 practice exams. I forget off the top of my head. I think practice exam A is the one that probably looks more similar to the exam itself. It's got like 25 questions. One of them, I think, has like 33 questions or 34. So it's more questions. I'm just trying to give you more possible questions you could see on that exam, right? So just more problems to work through, okay? So kind of like the exam, you might notice, sometimes I'll take 2 questions and kind of then make a 2-part question on the exam. So lots of kind of practice. I mentioned after the last exam how I would do this. Maybe sit down and take practice exam A, but then for practice exam B that has more questions, make sure you can provide a solution as to why every answer is the correct answer. I gave you the answer keys, okay? Other than this, I think that should cover everything in terms of housekeeping stuff. The only other thing, I don't know why I wanted to mention this, just because like I get really lazy and don't do it. And I don't know, I'm sure you guys are all way better than I am. But I don't know if you knew on Canvas, I can't have it do it for you. I can only set it from my account. But you can always minimize these. So if like the old stuff, you can always minimize these old modules so you don't have to scroll so much. This is also my just like pure laziness and not doing that in class sometimes. So just kind of, I don't know, something I wanted to mention if it makes it easier for you to kind of scroll and access Canvas. Yeah, so so we can talk about that a little bit next week. But basically, it won't be the Monday of spring break. It would be that Monday we come back, right? So, excuse me, Module 9 CL sessions will be next Thursday, and then that Monday that we get back from spring break. Is that what you're asking? Yeah. And we'll talk a little more about the exam and stuff next week as, before we kind of finish out and go to spring break. Okay. Any other questions before we get going here? So one thing I also did today, I put up the complete slides. I changed the order just a little bit based on how we'll cover things. So if you want to work along with me, you kind of have the same order on those complete slides. I also put up this Excel file, which is what we're going to start out with today, which matches up to slides kind of 19 through 21. So in these slides, I gave you prices, income, and quantities and the margin utilities of those different units. Right? So in this Excel file, we want to start thinking about how do consumers make optimal decisions. Right? So we said they face this budget constraint. Given the prices and their income, there's only certain combinations of these 2 goods they can afford. We said, which good do I want to buy more of? Whatever has the highest margin utility per. So you want to buy the highest margin utility per dollar, right? Not just the highest margin utility, you've got to factor in those prices. So the thought experiment, if I go to Starbucks and everything costs the exact same, what am I going to choose? Whatever would bring me the highest margin utility. Well, the fact that if I want to add, some syrup, cold foam, etc., get the larger size, the margin utility is going to increase, but also what's going to increase? My price. So why don't I get that kind of crazy drink? Because the margin utility is higher, the price is a lot higher, right? So we make this decision based off of the margin utility per dollar, okay? So I kind of have this set up. We'll get rid of this column and I'll kind of build it for us. And I'm not going to expect you to use Excel or kind of, interpret Excel on the exam or the quiz. But if I gave you the quantity and the margin utility of these two goods, so I think I've got chips and soda here, I created the column, and you could do this by hand, which is just simply taking that margin utility and dividing it by the price of that good. Okay. So all I did here was use some, freeze some cell references, which you haven't had a lot of experience in Excel. Maybe you don't know what that does. But basically, I can copy this down. It then uses that quantity's margin utility, but keeps dividing by the same price of that good. Okay. So if I'm thinking about this, I now have the margin utility per dollar of both goods. Now over here, I just kind of have a running total. As I buy a unit of a good, what's the total amount of money I've spent? That quantity times the price of that good. And I would add up that for both goods. So this is going to kind of keep a nice running total of how much money I've spent as we go through. So if I'm making the decision, do I buy the first bag of chips or the first can of soda? Well, what has the highest margin utility per dollar? 18 is greater than 6, so I would buy that first bag of chips. Right? Now, do I buy the second bag of chips or the first can of soda? Well, the margin utility per dollar of chips, so that second bag, is still greater than the margin utility per dollar of that first can of soda, so I buy a second bag of chips. And then do I buy the third bag of chips or the first can of soda? 12 is greater than 6. 9 is greater than 6. I spent $4, right? I bought 4 chips. Each one costs 4 bags, so each one costs $1. Now I think about, do I buy that fifth bag of chips or the first can of soda? Well, if they have the same margin utility per dollar, I would say that I am indifferent. Right? I get the same margin utility per dollar no matter which one I buy. So we'll say that, I buy each one of these, right? Kind of in consequence. I don't know which one I'll buy first, but that's kind of, I'll buy both, right? Now I've spent $7 here. I still have $5 to go, right? So if I'm spending all of my income, do I buy the second can of soda or the sixth bag of chips? Well, 5 is greater than 3, so I buy a second can of soda. Do I buy that sixth bag of chips or the third soda? 4 is greater than 3. Now I have $1 left. So here's a case where we kind of have a tiebreaker, because that fourth can of soda has the same margin utility per dollar of what? The sixth bag of chips? However, why do I know in this case I'd be indifferent about which one I choose, but why can I tell you which one you'll definitely buy? Yeah, I can't buy the fourth can of soda because it costs $2. I only have $1 left. So anytime you have kind of the same margin utility per dollar, if I only have enough money to buy one of those goods, I know that's the one I have to buy, right? So here our optimal consumption based off the margin utility per dollar and the income and price of that base would be what? 6 bags of chips, 3 cans of soda. Now, we'll go through another example that's kind of unique, and I think helps get a different point. So I calculated using these different prices, and I've got now a lower income, that I've got my new margin utilities per dollar. Well, first of all, if I have a lower amount of income, what's likely going to be true? I buy less of these goods. Okay? Now, if I go through this thought experiment, I use my margin utilities per dollar. Do I buy the first bag of chips or the first can of soda? Well, 9 is greater than 6. Do I buy the second bag of chips or the first soda? 7.5 is greater than 6. Now here, the third bag of chips and the first soda, I am indifferent. So I don't know which order in which I'll buy them, but those will be kind of the next two that I buy. Now, do I buy a second can of soda or that fourth bag of chips? Well, 5 is greater than 4.5. Now here's where, if I then say, okay, I've got $1 left to spend, technically here, would I buy that third can of soda or the fourth bag of chips? Well, I would buy the fourth, but I can't afford it. So there's these kind of weird scenarios where even though I haven't spent all of my income, I can't, right? Because I can't afford a whole unit of that good. So here we would kind of stop at 3 and 2. Okay. Does that make sense? Why? Any questions on that? Yeah. So I've got what? Oh,
You said each price for each bag of chips.
oh yeah, this should be 8. What did I do wrong here? So that would be 5. Oh, sorry. So I've got 5 times 2 should be 10. So what is this not factoring in? Oh, I forgot to update. I'm using the old prices. So what should I be using? Sorry. 12 and, or not 12. I have my cell references wrong because I was copying and pasting this. So this should be what? There we go. So if I go back here, I think this is what I wanted. Yeah. So now what can I do? All right, there I go. Right. So I'll buy 3 bags of chips and 1 can of soda. Forgot to update my cell reference. I was copying and pasting for class. Okay. Now, before we move to the next example, I want to kind of, with that, which is good I did that, just kind of make that point. But let's say instead I had $10. So I should be able to afford to buy more than I was before. So if I now still have $2 to spend, will I buy that 4th bag of chips or that 2nd can of soda? 2nd can of soda, I've now kind of used all of my income. So the next thing that we're going to think about is what if I go to this 3rd scenario, and let's make sure I've got, yeah, so for some reason, this file didn't update these. So I want this to be 25, 26. I used this for my last class and it was right. So I must have somehow rewrote over the file. Okay. So I'm going to get rid of this. And we'll kind of think through this example. Now, here I've got income that is the exact same as before. Right? Oh, what did I do? I accidentally deleted something I didn't want to. There we go. All right. So I've got the same income, but now the price of chips is higher and the price of soda is lower. So what should I do with my end result? I should buy less chips and more soda than before. So our old kind of consumer optimum was 3 and 2. So if I go through this same thought experiment, what would I kind of buy first? The first soda, 12 is greater than 6. 10 is greater than 6. So the second soda, 8 is greater than 6. So the third, here we're indifferent. So I don't know which order I'll buy them, but these would be the next 2 that I buy. Now, do I buy that 5th can of soda or the 2nd bag of chips? 5 is greater than 4. I've now spent all of my income. Sure enough, when the price of chips went up, what happened? My optimal point, I bought less. If the price of soda went down, my new optimal point, I bought more, right? So here, if I keep income the same, intuitively, I buy more of whatever is relatively less expensive, has a lower price, more of whatever has a relatively lower price, less of whatever now has a relatively higher price. And if I have more income, I potentially could buy more of both goods. Okay. Any questions on this before we keep moving? So you don't have to do this in Excel. You can create these margin utility per dollar columns by hand, and then you just kind of have to do this like running total of how much money have I spent and kind of do this back and forth to determine what am I going to buy next, all the way up until when I've spent all of my income.
We'll get to a point where we're indifferent, we don't wait enough to afford more.
That's what we did up here, right? So we had $1 left. The margin utility per dollar is the same, but I can't afford that soda because it's $2. So we said the tiebreaker was if I have the same margin utility per dollar, I have to buy the one that I can afford. Is that what you're asking?
I mean, like the same price and the same market utility, and then you'll make
Then what? I would be indifferent. I don't know which one I'm going to buy. All right. So like in this example, let's say I had, well, no, yeah, we would have to have different numbers. But yeah, the idea would be if I have enough money to buy both, but the margin utility per dollar is the same, I don't know which one I'm going to buy. So I wouldn't give you an example like that because technically the answer would be, I don't know, right? It's a good question. Any other questions on this before we kind of transition back to the slides here? Okay. So really what we're doing here is figuring out what we call the consumer optimum. What combination of these two goods do I want to buy, right? Given my budget constraint, the current prices and income. So we talked through this idea of indifference curves last class. So just kind of give a quick summary. We said any point, right, an indifference curve represents a total amount of utility. So it's the different amounts of these two goods I'm buying that gives me the same level of total utility. Okay. So any point on this curve, I'm getting the same amount of total happiness or utility. We then said higher indifference curves, moving further away from this 0, 0 point. Well, as I have more of both goods, what's happening to my total level of happiness? It should be going up. So higher indifference curves further away from this 0, 0 point represent higher amounts of total utility. We kind of went through the thought experiment behind why. We said they can't cross because that would kind of violate this idea that higher indifference curves have to represent higher levels of total utility. And we kind of ended on this idea of the marginal rate of substitution. So if I'm thinking about, if I'm on the same indifference curve, right, maybe not using these numbers, maybe something a little bit easier to think about. If I want to keep total utility the same, and let's say the last unit of good Y I bought, the margin utility was 2. And the margin utility of X is right now 10. If I want one more unit of X, that's going to change my total utility by 10. But if I want to keep total utility the same, how many fewer units of good Y would I have to buy? Well, if I'm getting 10 units of utility from X, to keep total utility the same, I need 10 less units of utility from Y. If each unit of Y is 2 additional units of utility, I'd have to give up 5. So it's going to end up being however many units of good X I want to buy, how many units of good Y I'm going to have to give up to keep total utility the same. Now, I went through an example last class, and I kind of worked out the algebra. I'm not going to do that for the sake of time here. But we kind of said the idea is if I want total utility, it's the marginal utility coming from both goods times the quantity that I'm buying. Now, in reality, these margin utilities are not a single value. There's actually a function behind them. Not going to make you do that complicated math. We can think about these simply being one value. So when I rearrange this equation, if I've got quantities on my X and Y axis, I want to write the quantity of Y as a function of whatever's on my X axis. This is how we would typically create a line, like a equation for a line on a graph, right? Y is equal to some function of X. So if we solved this for the quantity of Y without doing the algebra, just kind of showing you the end result, we had something that looked like this. So we did this at the end of last class. So this is my intercept. This is my slope of that indifference curve. Okay. So the slope of my indifference curve should be what we call marginal rate of substitution. And that's just going to be the relative margin utility of X to the margin utility of Y. So this looks similar to what we talked about with budget constraints, because I can use my quantities to find the slope of this indifference curve. But if I don't have the quantities, I also can use the relative margin utilities. Just like for a budget constraint, I can calculate the slope using quantities, but I also know that the slope of my budget constraint was what? My relative prices. So with our marginal rate of substitution and our budget constraint slope, it gets a little counterintuitive because it's not Y on the top now. We're not using the quantities. It ends up getting flipped where it's the margin utility of X over the margin utility of Y when I want the slope of my indifference curve. And when I want the slope of my budget constraint, we went through last class, the kind of algebra behind Y, it's going to be the price of X over the price of Y. So kind of counterintuitive results there, but we went through the math to prove kind of why that's the case last class. It's just kind of giving us a synopsis or summary of where we left off. Okay. So if we use this result, all right, the next thing we want to think about, and let me make sure I didn't skip anything. So this is basically what I have on the slides. Oh, we'll go through this first. And then I'll kind of maybe show you a nice visual to kind of go along with it. So I've got my marginal rate of substitution. Why is this true? And I kind of went through the idea, if I want to buy more X, the marginal utility I'm getting from good X, to keep total utility the same, to stay on that same indifference curve, I'm going to have to give up some of the utility from good Y. And how many units of good Y I'm going to have to give up would be the margin utility that I'm going to get from good X. You know, to get that amount from Y, I'd have to take the margin utility of Y times the quantity of Y I'm giving up. Okay. So with this idea in mind, let's say I was moving from point A to point B here. Well, I could calculate the slope simply using my quantities. So what's the change in the quantity of Y? Moving from A to B, the change is 2. Change in X, I'm going from 1 to 2, so that changes 1. So if I calculate the slope, 2 over 1 is 2. Now, technically, I have a downward sloping curve, so it's always going to be negative. Right? Now, if I'm thinking about what that slope is, it should be my marginal rate of substitution. Okay. So if instead of going from point A to point B, where I have this slope of -2, if I then move from point C to point D, without looking at those values, which I can calculate the slope using those quantities, but if I'm thinking about this indifference curve, and we just went through and said, for this indifference curve, the slope is my relative margin utility of X compared to that margin utility of good Y. So if I want to move, I think it was from point A to point B, and we calculated the slope was -2, right? Or an absolute value 2. If instead I'm want to moving from point C to D, well, if I increase the quantity of X I'm buying, what has to happen to the margin utility of X? So we said it's just like the demand curve. As I buy more, the marginal benefit, utility is another word for benefit, must be decreasing. So if the margin utility as I buy more of good X, if the margin utility is decreasing, what's happening to this slope? It's going, the numerator is smaller, my fraction is smaller, so my slope is getting closer to 0. Notice as I buy more of X, the slope of my indifference curve is getting flatter and flatter. All right. So, excuse me, I can think about if I know the value is 2 here, it must be something that is less than in absolute terms, less than 2, right? Closer to 0. Okay. Or my marginal rate of substitution, which was represented by this fraction, is going down. Okay. Now, sure enough, if I look at that graph, if I don't use the margin utilities and I instead use the quantities, well, if I want to go from point C to point D, how much is Y changing by? 1. How much is X changing by? 4. 1 over 4 would be 1/4. Sure enough, my marginal rate of substitution, as I want to buy more of X, is going down. Right? Our initial point we started out at from A to B was a slope of 2. Now it's a slope of 1/4. Okay. And then I could calculate, right, the slope between any other 2 points if I had like a continuous like grid line here. So I can use the quantities, but I also know that that slope represents the relative margin utilities. Very similar to the budget constraint. I can calculate the slope using the quantities. I also know that slope will always be my relative prices. Okay. Any questions on this before we keep moving? Okay. So let's now combine these things together. We kind of technically did in those examples we worked through in Excel. But basically, we want to get to the highest level of total utility. If money was no constraint, I would just buy more of both goods, and I could always increase my total happiness, right? But I can only afford to buy a certain amount. So we're going to want to take this idea of the indifference curve and see what's the highest indifference curve I can get to facing my budget constraint. Because we said any point past my budget constraint, can I afford any point that's on this fourth indifference curve? No. Now, if I was on these lower indifference curves, these are all points I can afford, but I'm not doing what? Using all of my income. If I'm on my budget constraint, using all of my income, what's the highest total utility or the highest indifference curve I can get to? This third one. So we'll kind of talk about that highest level of utility or the highest indifference curve I can get to facing my budget constraint is at a point of 4 units of Y and 3 units of good X here. But why is this going to be the case? All right. So we'll kind of go through this thought experiment and then I'll kind of show you the end result. Okay. So let's assume that I'm buying 2 goods. Here's my budget constraint. Okay. Now let's say originally I'm on this indifference curve and we could put some number to the units of utility or some value to total utility here. If I was spending at this point, remember, what is the slope of my indifference curve? The margin utility of X over the margin utility of Y, right? So if I think about that marginal rate of substitution, that represents the slope of my indifference curve. What is the slope of my budget constraint? So we said that was the relative price of good X to the price of good Y. At this point, what is true about the slope of my indifference curve? And just to kind of be complete, here the slope of my budget constraint is always the relative prices, right? So here the slope of my indifference curve is steeper than the slope of my budget constraint, so it must be greater, right? If that's the case, if I rearrange these equations a little bit, so I do the algebra, I multiply both sides by the margin utility of Y. Sorry. Yeah. Is that what I want? Yeah, margin utility of good Y. I then divide both sides by the price of good X. This cancels. This cancels. I'm left with the margin utility of X over the price of X is greater than the margin utility of Y over the price of Y. It's just the algebra, right? I'm moving things around a little bit. Well, if this is the case, then at this point A, what is true? The margin utility per dollar is higher for X. So what do I want to do? Buy more of good X. Now, I was spending all of my income at this point. So if I want to keep spending all of my income, I start to buy more of X. If I buy more of X, what's happening? So I buy more X. What's happening to the margin utility of X? It's going down. So these two things are getting closer to each other, right? This might still be greater. So maybe I think about now the indifference curve I'm on might be kind of here. Well, I'm spending all of my income, but that margin utility per dollar, the slope of my budget constraint is still flatter than the slope of my indifference curve. So the margin utility per dollar will still be greater. So what do I want to do? Keep buying more X. As that occurs, I'll keep doing that until I get to a point where there's only one point I can afford on this higher indifference curve, right? So every other point on this indifference curve is unaffordable. Okay, there we go. As that margin utility of X keeps going down, as I'm buying more of good X, eventually there comes a point where those two things are equal to each other, at that point, do I want to buy more or less of good X? At this point, I would be indifferent. So if I buy more of X, that would lower the margin utility per dollar of X. I would now then want to go back to buying more of good Y. We said this is kind of the point that we're going to stop, right? We're not substituting towards one of these goods. We kind of are spending optimally. Now, what is this really saying? If this now becomes an equal sign, we're saying that the slope of the indifference curve is the same as the slope of the budget constraint, right? So when we're thinking about this consumer optimum, getting to the highest possible indifference curve, given that budget constraint we're facing, what happens to the slope of our indifference curve and the slope of our budget constraint? They're the exact same thing. And kind of the thought process behind why is what we just worked through. Okay. Any questions on that idea before we keep moving? Okay. So I'm thinking about when I'm in this consumer, when I get to this consumer optimum, the slope of my indifference curve is the same as the slope of my budget constraint. Rewriting that, what that's really saying is the margin utility per dollar I'm spending on both goods is exactly the same. I have no incentive to change my current combination of X and Y because I'm getting the same margin utility per dollar for the same bang for my buck. Right? So this is the point that we'll stop, right? So kind of given this, we'll go here. And so how much time do I want to, it would be 10. We'll have plenty of time. Actually, this should give us more than enough time to kind of work through this. I believe the answer or the code is 53.67. So let me know, confirm, I can look it up if that's not right, but I believe it's 53.67. So the in-class quiz should be kind of under that homepage now or under the quizzes tab. 53.67 getting you guys in. Yes, no. Yes, okay. I remembered it correctly. So if we look at, there's two questions here. I've got this set, what I do, 10, I think it was 10, 11 here. So I'm going to feeling nice and friendly. We're doing this early in class, kind of showing you there's an incentive to showing up on time, right? So if I give you this visualization, we're going to start to think about what's true. Okay. So first of all, what's the highest indifference curve here? A, B, or C? A, it's the one that's furthest from that 0, 0 point. Okay. Now, point J would represent a point that I can't afford. My budget constraint is this line here. What's the highest possible indifference curve I can afford? B. What should be true is when there is only one point on a indifference curve I can afford, that means that I've gotten to the highest possible indifference curve given the budget constraint I face. So point I would actually represent our consumer optimum. Now point G, H, and K would all be points that give me the same what? They're on the same indifference curve C, so they would all give me the same amount of total utility. Now, of those 3 points, which are the only two I can't afford? G and K. All right. So if I'm thinking through which of the following is true, is J going to provide a lower level of utility than H? No, it's on a higher indifference curve. So that one's not going to be true. Okay. Is point I and J, are they both unaffordable? Well, we said J is unaffordable, but I is on my budget constraint. So that means I am using all of my income. I can't afford that point. All right. So those two aren't true. H and K are both using all of my income. This is a little tricky. Right? Am I using all of my income at point K? Yes, it's on my budget constraint. Am I using all of my income at point H? No, it is a point I can afford, but I still have money left over. I could afford all these points to get to higher indifference curves right here. So that's going to be the one that's not true, right? Wait, yeah. So I'm not using all of my income. Point H and G would give me the same amount of total utility. Is that one going to be true? If I'm on the same indifference curve, I have the same amount of total utility. So yes, that's the one that is true, right? And then I think I have this to shuffle the answers, so these might not be in quite the same order as I'm going through them here. Now, if we know this one's true, hopefully this one's not true, right, for there to be one answer. So does point G provide a higher amount of utility than point J? Even though it looks like it's at a higher point here on the y-axis, it's on a lower indifference curve. So if it's on a lower indifference curve, it means it's providing me a lower level of total utility. So that's why that one wouldn't be true. Okay. Any questions over that before we keep moving here? So that one will be graded for correctness today. This one we haven't talked about yet, and I don't think we'll have time to revisit it, but we're going to be going through kind of similar examples. So this would be a good one to use as a practice problem, like after class. It's set, so it'll show you what the correct answer is. So this is a good one to work through on your own. You have to give an answer to it, but after class, when I get back to my office, as long as you put an answer in here for the second question, I'll give you full points, right? Now, for the first one, it's still going to be graded on, were you in class? We worked through it together. Did you hear, or did you kind of understand what the correct answer was? Okay. Is that clear to anyone with any questions on that? So you need to get the first question correct, earn the full points. Any answer to the second question will get you full points for that second question. Okay. So I had it set to be what, 10, 11, I think. So make sure you're getting those answered, hitting submit in the next minute or two. That way I know you were in class. You got it submitted on time. Okay. Now I'll look at this after class. My phone is like a couple minutes ahead of the time on the computer. So I'll double check to make sure it's not going to treat like everyone's as late. I don't know what that difference is being caused by. So if for some reason you submit, it looks like it's late here, I'll change that due date to adjust for the fact that the actual time is like 2 minutes off or something by what the actual computer shows. But make sure you're getting it submitted here. It should be working correctly. I'm just a little bit worried about that, so I wanted to mention that. Okay. Any other questions before we kind of jump back into the slides here? Okay. So we'll eventually start talking about that second question, which was this idea of I can break things down into what we call income and substitution effects. So before we do that, we need to understand how income effects work. Okay. So if I'm at this consumer optimum, I've gotten the highest level of possible total utility given my current budget constraint. What happens if income changes? Okay. So I left this slide open to kind of draw this out. But here, if I'm buying two goods and I've got my budget constraint, and let's say the highest indifference curve I can get to here, and I know my drawing, I'm not always perfect, right? Because these are thick markers, but there should be one point here where it hits that indifference curve, okay? So this is kind of the point that we started out at. Just intuitively, if I have an income increase, should I be able to afford a higher or lower level of total utility than before? Higher. So if we remind ourselves, where did these points come from? If I'm only buying X, how much can I afford to buy? Whatever my income is divided by its price. Whatever the income is divided by this good's price. So if I see an increase in income, what's going to happen to these 2 points? They're going to shift out, right? Now, all these points before used to be unaffordable. I can now afford to buy these points. I can afford to get to higher indifference curves. Okay? Now, just as a kind of reminder, what was the slope of our budget constraint? Our relative prices. When income changes but prices don't, what would happen to the slope of our budget constraint? Stays the same. Prices haven't changed, right? So what's the highest indifference curve I can now get to? Out here at a higher level of total utility. Okay. So I don't think this is too bad. When we have income changes, it's going to cause this nice parallel shift in our budget constraint, allowing us now to get to a point where we're on a higher indifference curve. Any questions on this idea? Now, what if I had an income decrease? What's going to happen to my budget constraint? It's going to shift down, in which case, can I afford to be on the same indifference curve I was before? No, it's now past my budget constraint. So, now I'm down here, I don't know, at a much lower level of total utility, right? I can't afford to get as high of an indifference curve as I was before. Okay. And I know I'm using colors here, but that's why I try to use subscripts as well. So you can kind of line up with, right, this was our income decrease. That second one was our income increase. Okay. Any questions on this idea? Because we're going to reuse this here in a second to, instead of look at income changes, to look at price changes. Okay. We're okay with this? Okay. So we're now going to instead look at something a little bit different. Okay. So let's again assume, and here I want to remember what I did in the slides real quick, just so I give you more examples. So I did, okay. So let's say I've got two goods that I'm buying. Here's my original budget constraint. And here's my original indifference curve, right? So my consumer optimum is when I've gotten to that highest indifference curve. There's only 1 point on it I can afford given my current budget constraint. Okay. If I have the price of the Y good go down, okay. Well, intuitively, if Y is cheaper, should I want to buy more or less than I was before? The price goes down, I want to buy more of it, right? So we'll kind of think through, if my price of Y goes down, if I'm only buying X, how much can I afford to buy after this price change? Did either one of these things change? I can afford to buy the same amount. Now, if the price of Y goes down, how much of good Y can I afford to buy if I'm only buying Y? A higher amount, right? So here is my new budget constraint. We talked about how to draw this last class. Now, the reason why it's steeper is because if the price of Y goes down, what happens to this fraction? Goes up, right? So the slope of my budget constraint is changing. If I think about this higher indifference curve that I'm on, here's like my new consumer optimum, okay? So maybe I think about here's point A, here's point B. Moving from point A to point B is going to represent what we call the total effect. It was the total effect of this price change. Okay. Everybody with me on that before we keep moving? Also, give me a little bit of response here. It's kind of hard for me to see well, they both kind of look the same. Does either one of these look like a different color to you more than one of the others? Blue, green, they're about the same. Okay. So I'll try to use subscripts so we kind of think about this. So here was my first budget constraint. Here's my second budget constraint, right? Kind of using those subscripts. So if the colors don't show up well, we can still do this. So let's assume for a second that I've got, oh, what do I want here? I've got this hypothetical budget constraint. Now, what this hypothetical budget constraint is doing is it's saying, let's assume, right, that I've got the same, I'm facing the same kind of relative prices as before. So let's assume, even though I know the price of Y went down, right, when the price of Y goes down, what's going to happen to the real value of my income? So this is inflation. If I have $50,000, price of everything doubles. It's almost like I only have 25,000, right? Half as much as before. So when prices go down, what's going to happen to my real income? It's going to go up, right? I can now afford to buy more with the same amount of dollars in my pocket. So if I'm moving from point, let's say, here's my new kind of hypothetical prices. Let's say I've got something like this, right? So I know that it's hard when I'm drawing this out. I'll have some things in the slides where it's a little bit more obvious. But let's say this is like my hypothetical point C, right? So this isn't my actual budget constraint. The red line was kind of my new budget constraint. This hypothetical budget constraint is saying, assume that the relative prices remain the same, but I know that when the prices go down, I have more real income. So what does that shift look like from my old budget constraint to the hypothetical one? It looks like a change in income. That was a parallel shift. So when I move from point A to point C here, this represents my income effect. Okay. So notice what happened here. The income effect did what? It increased the amount of good X I was buying, but it also increased the amount of good Y I was buying. Okay. Everybody with me up to this point? Okay. Now, if I broke this down, and I'm now thinking about moving from point C to point B, we're going to call this the substitution effect. Because what this is assuming is it says, assume that I could afford to be on the same indifference curve. Even though we know when the price changed, it caused a change in my real income, assume that I kept real income the same, that I can still afford to buy the same amount of total utility before and after this price change. However, I'm allowing for that budget constraint to change by the fact that when I have a new price, the relative prices will change. So the relative prices will tell me what we call the substitution effect. So moving from point C to B, well, when the price of Y goes down, from substituting, what should I buy more of? The price of Y is lower. Do I want to buy more or less of good Y than before? I want to buy. Not breaking news here. When the price of something is lower, do I want to buy more or less than before? More, which means if I'm buying more of Y, to keep total utility the same, I'd have to buy less of good X. So here's where it gets to be kind of weird. Even though I can identify the total effect if I gave you the graph, if I didn't give you the graph, you can think through. I can see visually here these changes happened, right? That substitution effect said I bought more of Y but less of X. But if I didn't give you this graph, the intuition is all there, right? So what is the total effect going to be? Well, if the income and substitution effect for good X are pushing them in opposite directions, the total effect is going to be, it's kind of like simultaneous supply and demand shifts. If they're pushing quantity in opposite directions, the total effect would be indeterminate. I don't know. You have to tell me which of these effects is larger. Now, the effect of this price change on good Y, I definitely know it's going to increase the amount that I buy. All right. Now, one thing that I'm assuming here is that both of these goods, if my real income goes up, if I'm buying more of both of them, I'm assuming that they must both be what type of goods? Normal goods. So this is where it's not going to be a cumulative exam, but we're reusing concepts we talked about way back in module 3 and 4. Okay. So this is how I can look at these income and substitution effects visually. Here's how I can break them down by hand. It's very difficult to draw these graphs. Even like I said, you can kind of see here, it's hard for me to get the lines to exactly match up. So more likely than not, I'm going to ask you questions where you have to think through what the substitution and income effect would be and then determine the total effect. And sometimes the answer might be indeterminate. Okay. So we'll work through more of these examples, but this is kind of the first one that I wanted to think about. Okay. So any questions here before we keep moving? Where are we at in time? Okay, perfect. All right. So let's look at a different type of price change. Okay. So what do I have drawn out here? I didn't draw out the hypothetical budget constraint. I just drew out the before and after. Okay. So before I was on this old budget constraint, and I could afford to get to this higher level of it, or a higher level of total utility, or this higher indifference curve 1. Now, if I saw no change in my budget constraint on the y-axis, but I saw that the intercept of my x-axis went down, what good must have had a price change? Good X. In fact, if I now can afford to buy less of it, when I'm only buying that, it must have been that the price went up. So instead of a price decrease, I have a price increase, right? So I've moved from 0.43 to, on my new budget constraint, the highest indifference curve I can get to is this second one, right? This makes sense. When prices go up, can I afford to have the same amount of total utility I was before? No. I'm going to move to a lower indifference curve. Now we can walk through this one, and I'll kind of, it's very similar, but instead of looking at the graph for a second, I just want to break this down. Okay. So let's assume that I have two goods and they're both normal goods, right? We just said the price of X went up, right? So when I'm thinking about the income effect, how would that change the amount of both goods I'm buying? Well, if the price of X goes up, what happens to my real income? I've got the same $50,000. Everything's twice as expensive. What's the value of that $50,000? Less. I can't buy as many things. So when prices go up, my real income goes down. For normal goods, that would mean if I have less income, I would buy less of them. So back in module 3 and 4, we were kind of being lazy when we talked about income effect, because we were saying when income goes up or down, I buy more or less of, if income goes up, I buy more of a normal good. Technically, people make decisions not just off of their income, they make decisions based off of their real income, right? If I keep making the same amount of money every year, in 20 years, what's going to happen? Prices typically are always going up. We have inflation. So if I keep making the same amount of money year after year, I'm going to be able to afford to buy a lot less in 20 years, right? Making $50,000 in 1950, I was living a much more lavish lifestyle than making $50,000 today. Okay. So I've got my real income in effect. What's my substitution effect going to be? The substitution effect should be easy, right? It's always I substitute away from whatever is now relatively more expensive, and I buy more of what is ever relatively cheaper. So if the price of X goes up from my substitution effect, and it might always help to think about the good that had a price change first. If X is more expensive, am I going to want to buy more or less than before? Less. And this really comes from the fact that what was happening when the price of X went up? The margin utility per dollar was actually going down. So I'm going to buy less of good X, but now what is relatively cheaper? So I'm going to buy more. So in this case, what is that total effect going to be? Well, I know that I'm going to buy less of good X, but I don't know what's going to happen to the good Y. Unless you tell me one of these is larger than the other. If you told me the income effect is larger than the substitution effect for Y, then I know that I must be buying, that income effect must be large. Right, sorry. If I told you the income effect is larger than the substitution effect, you would then know the total effect must be that I'm buying less of good Y, or vice versa, right? But in order to not say it's indeterminate, I would have to know something about the size of each one of those effects, okay? Which is why when I gave you the visual here, what could hypothetically happen? When the price of X goes up, the quantity I buy of Y we said was indeterminate. One of the possibilities is I could actually buy the exact same amount. So here, I kept buying 3 units of good Y here, but I bought less of good X. And I think I stole this from another image, but these are kind of written out of order, right? 3 is going to be, well, it's written as X and Y, right? Does that, any questions on that idea? So we kind of looked at two different price changes on two different goods, and we kind of worked through how we would determine the substitution income and the total effect. Okay. So I kind of left this slide open. We kind of went a little bit out of order there. I thought drawing it out might first help before we kind of looked at a different example in the slides. Okay. So we can work through these substitution income effects. Now, I drew this out as both goods were normal goods. Okay. What could happen is that I instead have inferior goods. So we'll work through one more normal good model just to kind of give you a visualization of hypothetical budget constraints. And then I'm going to start to talk about inferior products. Okay. So let's say I have pizza and soda, and I've got the price of soda falls, so it decreases. So which of these points is going to change, 300 or 1200? Well, if the price of soda falls, I can now afford to buy more of it, right? So we're going to see that my budget constraint shifts outward, right? So if that's shifting outward, if I think about the new optimum, it's going to be out here at this higher difference curve. So the total effect is that I did what? I bought less of Y and I bought more of good X. That's my total effect. So another way of thinking about this hypothetical budget constraint, a little different than how I drew it out before, but still tells us the same thing. So here's my new budget constraint. What I could think about is, I know when the price of this X could change. Well, my slope of the budget constraint was my relative price. So I know that slope is going to change. Okay? So let's think about if I was facing these new relative prices, but I could only afford to buy the same amount of total utility as I was before that price change. So what I've done is I've essentially eliminated the income effect on this hypothetical budget constraint, and only I'm looking at, well, what is that change in the consumption due to the change in relative price? Or what is that substitution effect going to be because those margin utility per dollars aren't the same. Right? So I'm on the same indifference curve, but I'm not facing the old relative prices, I'm facing the new ones. Right? No change in my real income, just the change in this relative price. So moving from point A to point B would represent my what? If I shut down the real income effect, the only effect I have left is my substitution effect. Intuitively, if the price of my X good has went down, should I buy more or less of that good when I'm just thinking about substituting? More. So sure enough, moving from point A to B, what's the substitution effect for X? I buy more of it, which means if I'm on the same indifference curve, I would have to buy less of good Y. So that's my substitution effect. Now, if I'm moving from this hypothetical budget constraint, I'm facing my new relative prices. But if I'm thinking about, I know that when prices go down, what's happening to my real income? Going up. So when we draw these income changes, it's really changes that are coming from my real income. So I'm facing my new relative prices on the old amount of utility I could afford, but I'm now looking at what is my new higher real income, a parallel shift. So I've kept the relative prices the same between my hypothetical budget constraint and my new budget constraint, but I'm now allowing for the fact that I know when prices are lower, my real income is higher. So if I'm moving now from point B to the new kind of consumer optimum point C, I've got the same slope, relative prices haven't changed, but I have a higher budget constraint that's capturing the effect of my real income going up. Moving from point B to C would represent my income effect. Okay. Now, here's a situation where I could kind of think about, if I were to kind of write a summary of this, right? Moving from point A to point B, that was my substitution effect. Okay. So the substitution effect for good Y was what? I bought less of it. B to C is the income effect. The income effect on good A that I bought more of it. They're working in opposite directions. Well, if I know the total effect is I went from A to C, the total effect is I bought less of good Y. So what effect must have been larger? the one that was decreasing the amount of Y I bought. What effect was decreasing the amount of Y I bought? That substitute. So in this case, because I can look at the total effect, I know the substitution effect must have been larger. If I didn't give you that point C, right, like there the answer could be it's indeterminate, right? We have a substitution income effect working in opposite directions. Okay. Any questions on this before we keep moving? Yeah.
See some effect based on how substitution effect affected the first difference curve.
Say that again.
So why does the income effect parallel to the hypothetical budget constraint of the subject?
Because
and not the original.
So the hypothetical budget constraint is saying, let's assume I can afford the same amount of total utility. So I've shut down the income effect, but I'm facing my new relative price. So the only effect that's going on now is just the change in my relative prices or my substitution. Going from my hypothetical budget constraint to my actual new budget constraint is saying, assume that relative prices haven't changed, but that I now, because of this lower price, have more real income. So that's why kind of looking at that hypothetical budget constraint to my new budget constraint, that's just telling me my income effect, or my real income effect. Yep. Any questions on this before we keep moving? Okay. So I'm not going to dive too much into this idea of substitutes and complements today, just for the sake of time. We might revisit this at the beginning of class on Tuesday. So I wouldn't expect you to know anything about substitutes and complements in terms of the quiz this week. So we'll kind of gloss over these slides for a second. I've got just another depiction of substitution and income effects with kind of hypothetical budget constraints. We've done enough of this. This was just kind of an additional way of looking at it. We've really already drawn these models out. So this is just something I had from the textbook that I think kind of does a good job of also showing substitution income effects. But we've drawn plenty of them out, and I had them in previous slides. So I'm just kind of throwing this in there for an additional resource that gives you a visualization if you weren't in class and you don't have what we drew out. Okay. Now, I'm not going to go through this in too depth because we've really already talked about these things. Okay? I've already worked through models where we're showing the directional changes of income and substitution effects. But the one thing that we could see is not normal goods, but also inferior goods. How would I work through these substitution and income effects? And then we're actually going to talk about a third type of good, which is an inferior good, which results in a really weird result, which is called a Giffen good. So I'll kind of work through that now, and then I'll show you a visualization. I would never ask you to produce the graph for a Giffen good. It's very hard to do so. But I'll show it to you just to kind of confirm what we're kind of talking about, not using a graph, but kind of drawing these directional changes with arrows. Okay. Everyone with me? Okay. So let's assume I've got two goods. So I was thinking about this. So there's this distillery in Indianapolis called Hotel Tango. And they just like sold out. But they make really good whiskey. They like distribute everywhere. They're like in every liquor store here. So let's think about I've got that, and then I've got like Kentucky Gentleman or some cheap whiskey that nobody really wants to drink, right? So here I've got a normal good, and I've got an inferior good. Okay. So let's think through what happens now if I have price changes. Okay. So let's assume, if I can draw this out, that I have a change in the price of that inferior good, right? And let's assume that the price goes up. Okay. So this actually, let's make this a little bit easier. I think this will maybe make a little bit more sense. And it doesn't matter which way we draw it, but this might line up a little bit more with the way that you guys kind of probably think as consumers. So if the price of this good goes down, what's going to happen to my real income? If prices are lower, my real income goes up. So if I think about this income effect for both goods, right? So I've got both goods here. For a normal good, when my real income goes up, I'm going to buy more of it. right? But for an inferior good, if the real income goes up, I'm actually going to buy less of it, right? In all of our earlier examples, we were looking just at two normal goods, so the income effect was always, a little bit easier to think about. But with inferior goods, it's going to work in the opposite direction. Now, it doesn't matter if they're normal or inferior. Our substitution effect always works the same way. I buy more of whatever is now relatively cheaper, less of whatever is relatively more expensive. So if the price of this product went down, what's going to happen? Am I going to buy more or less of that than I was before? So if the price is lower, I want to buy more of that good. It's relatively cheaper. The other good is now relatively more expensive, so I'm going to buy less of that good. Well, notice we kind of get this really weird outcome where the total effect for both goods is what? Indeterminate, right? And in fact, we could get this really weird result, right? So let's assume that the substitution effect for this good that experienced the price change was actually, what do I want here? Less than the income effect. So if that's the case, right, what could I actually see? Well, if the substitution effect, was increasing the amount of this good I bought, but the income effect, well, here it is. Income effect is decreasing how much I buy. What would be my total effect here? It wouldn't be indeterminate. I know if the income effect is larger, I would actually buy less of that good. Well, what does this result suggest? That when the price of this good went down, the total effect was that people actually bought. That seems really counter to everything we've talked about. Because if prices are lower, should I want to buy more or less of that good? Typically, we think of as more, right? When I'm thinking about that demand curve, right? When prices are lower, I want to buy more. But that's because our demand curve really only captures the effect of price or this substitution effect. When we look at these more complicated models where I'm not looking at the price and quantity of the good, I'm looking at the quantity of both goods I can buy, we now are incorporating the prices, the substitution effect, but also when prices change, the effect that it has on real income. We're now kind of looking at both things simultaneously. So if this ever ends up being the case where the income effect is greater than the substitution effect for an inferior good, we would call this a Giffen good. It kind of goes against our intuition, right? But that's because the substitution effect is still the same as like we would typically think. When the price of a good goes down, I'm going to buy more of it. But it's because maybe I was spending so much of my income on this good, right? That when the income effect kind of increased how much I was buying of it, and that was the one that kind of won out, well, maybe now I see that like I'm actually, when I combine those two things, I'm going to get this kind of counterintuitive result. Okay. Any questions on that idea then before we keep moving? All right. So no questions. Okay. So I want to give you a visualization to go along with this because it's hard for me to draw this out by hand. You'll kind of see why, right? So if I think about how I would draw out these Giffen goods, now once again, the quiz or the exam, I would only expect you to kind of draw it out with these directional changes and thinking about the size of those effects, what the total effect is going to be. Sometimes it would be it's indeterminate. Okay. So let's say I had this good and it looks something like I had the same two goods and it's looking something like this, right? If I see that the price of my x-axis good is going, what must be happening? If I can buy more of it than I was before, the price must be going down. If I keep buying the same amount of the other good, must have been I had a change in the price of my X good here. So if I think about the total effect, well, the higher indifference curve I can get to now is actually going from point A to point C. So even though the price of the x-axis good went down, what's the total effect? I buy more of the y-axis good, but less of the x-axis. Sorry, did I say that right? more of the y-axis good and less of the x-axis good. And this is our counterintuitive result. We end up with a total effect that doesn't make sense the way we usually talk about things. The good got less expensive, and I actually bought less of it. So if you think about the intuition behind why, if I was spending a good amount of my income on whiskey, right, and all of a sudden the price goes down by a lot, I'm essentially like having a lot more income to be able to buy something else. And so maybe now I buy more of this like nicer whiskey, right? So that's kind of the intuition behind why this can occur. Right? Yes.
So one is a normal good and one is an inferior good, or can they both be normal?
So in order to be a Giffen good, we have to have that good be inferior. So the only way we get this counterintuitive result is if the product we're looking at is inferior. Is that?
Yeah.
So we could do a kind of similar thought experiment where we build in this hypothetical budget constraint. So in this hypothetical budget constraint, whoops, I'm hitting the wrong arrow. This is where it's hard to draw even using like lines on this graph. So let's say if I don't allow for the real income effect, I just allow for a change in my relative prices. I can afford the same amount of utility, but I'm facing these new relative prices. If I move from point A to B, I've shut down the income effect, and I only have my substitution effect. So the substitution effect is going to be I'm now buying more of that good that had the price decrease, less of the good that didn't. Right? Now, moving from point B to point C tells me, okay, if I was facing the same relative prices, but I'm now allowing for that real income change that was caused by the price decrease in one of these goods. Well, notice what is the income effect from B to C here? I'm going to buy more of that normal good, but I actually bought less of the inferior good. And in this example, that income effect is larger than the substitution effect, which is how I kind of end up with, oops, sorry, right? Which is how I end up with this Giffen good. I think it must be have a different PowerPoint version on here than what I created this, created this with, but this would kind of represent a Giffen good example here. Okay? That doesn't always have to be the case. Like we can end up with these situations where the total effect, even though it's inferior, we could still see the total effect be that I bought more of that good, in which case that kind of lines up with our general intuition. The price of the good went down. I ended up with a total effect. I bought more of it. So we don't always have to have an inferior good is going to be a Giffen good, right? We could have inferior goods that are not Giffen goods. It's just that every Giffen good, in order to get this kind of counterintuitive result, it would have to be inferior because that income effect would have to be working in kind of the opposite direction. Okay. So what else do I have here? Okay. So before I keep moving, any questions before we keep moving? So once again, less likely for these inferior goods and Giffen goods to give you these visualizations, and you won't necessarily have to reproduce them. But in order to understand them, you're going to have to do something like this. Think through what that income, what the price changes effect is on real income. Then think about if it's a normal inferior good, what would the income effect be? And then that substitution effect should be relatively easy. It's always I buy more of whatever is relatively more expensive. Or sorry, more of whatever is now relatively cheaper, less of whatever is now relatively more expensive. Okay. All right. So before I let you guys get out of here, right, I've got something I want to kind of mention. So on Tuesday's class, I'll kind of start out maybe revisiting this topic with something I think you might have been thinking about this whole week, which is why do I have to spend all of my income? So we can model these things in a way that allows us to think about why we are technically spending all of our income, but it's a slightly different way. So we'll revisit this topic just so I address that, maybe concerns some of you might have had, and then we'll jump right into module 9, okay? Other than that, my office hours are kind of the same next week, Monday and Wednesday. Have a fun, safe weekend, and I will see you guys on Tuesday.